Hello, math people. Here what we're going to do is we're going to do some more advanced solving trig equations. So I've got three here for us. Without further ado, let's get started. There should be a squared here. All right, what I want you to think about when you're solving these, especially these first two examples we're about to do, think about solving them the way you would something like this. If you just had x's with no trig function. My goal would be to get x alone in this case, right? So I'm going to do the same thing here, but in this case, my goal is to get this entire trig function alone. So to do that, I'll move the or the 3 over and then divide by 4. And then cosine squared x means cosine of x squared. So the inverse of something squared is to square root it. So when I square root both sides, don't forget that you have to plus or minus the right-hand side here. So what's weird about this is this is not in this table, so I'm not quite sure what to do, but I have faith. Let me mess with this a little bit. I don't know what the square root of 3 is. Well, I do, but it's irrational, so the cleanest way to write it is the square root of 3. And hey, the square root of 4 is 2. And the square root of 3 over 2 lives um, in this cosine row. It's right here under pi over 6, okay? So now I have to take into account that I've got plus or minus. What that means is that I know I want the positive and negative values of cosine in this case. So I'm actually going to have 4 answers, okay? So the values of x that will make cosine spit out rad 3 over 2 is, of course, pi over 6, and that's in quadrant 1. So I have to get the guys in quadrants 2 and 3. So that will be 5 pi over 6 in quadrant 2, and then 7 pi over 6 in quadrant 3. Last but not least, I need the last spot where cosine is positive. That's in quadrant 4. That's one increment away from 12 pi over 6, so my final answer will be 11 pi over 6, and I've got, wow, 4 fun answers. And I probably should have said this in the beginning. We're solving between 0 and 2 pi, okay, for our domain. Now, for one like this, just like I said earlier, think about solving a question like this. It's going to be exactly the same. With something like this, I would factor, and so in this case, I'm going to factor, but instead of factoring with x's, I'm going to factor with signs. So I've got 2 sine of x and sine of x. And so, oops, 6. And so from here now, I just need to factor this. And so factoring with a leading coefficient greater than 1 tends to be different based on like how you learned how to factor. But for me, when I factor this guy, um, here is what I will have. 2 sine of x minus 3, and then sine of x plus 1. Okay, and so now that he's perfectly factored, I will set each piece equal to 0. So 2 sine of x minus 3 is equal to 0, and sine of x plus 1 equals 0. So in this case, I've got sine of x equals 3 halves. Now that's weird. It doesn't land in my table. And I just want you to think about the graph of sine of x. Will sine of x ever equal 3 halves or 1.5? Well, since my range is from -1 to 1, 1.5 is up here. So this is out of range. So I will not get a answer from here. Okay. Lastly, I just have to get sine of x by itself here. Sine of x equals -1. That is not in my table. Sine of x equals -1 I can get from my graph. It's right here. And that is at 3 pi over 2. And so I'm done. So that was a pretty complicated question for a very simple answer of 3 pi over 2. All right, last but not least, let's come down to this guy. Cosine squared x times cotangent of x equals 2 cosine of x. All right, this one's a weird one, and I'm going to tell you, you're going to want to factor him. So I'm going to get it equal to 0 first. So cosine squared x cotangent x minus 2 cosine of x has to equal 0. And then what I will do is I will factor my cosine out. So, coast, oops. Here, coat. So I'm not sure what else to do, but I do see that they each have a cosine. So if I factor it out, maybe that'll be um, helpful. So if I factor out my cosine, um, actually, I think this was supposed to be a squared. Okay. If I factor out my cosine squared of x, I'm left with cotangent of x minus 2 equals 0. And now, last but not least, I just have to set each piece equal to 0. Wait a second.